Hello everyone, I'm Braden from EG4 bringing you our LiFePOWER4 Communication Hub. This hub is the solution to a closed-loop EG4 system simplified. It gives your LiFePOWER4 battery access to a wide range of inverter BMS protocols so that you can communicate with the inverter that you have. It also extends the LiFePOWER4's reach by giving it access to CAN protocol BMS communication. Closed-loop communication on a solar system is extremely useful for helping to optimize your battery's life and charge by giving your inverter the information it needs to determine its parameters, as opposed to having to set up static set points. Our battery's BMS knows what it wants, so this helps your system all speak the same language. The LiFePOWER4 Communication Hub also comes with a microSD card slot that acts in a similar vein to computer RAM. You need to make sure that you have an SD card inserted so that your communication hub can pull and save that battery data so that you can pull it from the hub. Let me show you how that works. Alrighty, so we're going to take a look at how to use the BMS test software to actually measure the logs that are coming from your battery bank. So first, you want to make sure that you have the BMS test version that is specific to the communication hub. Once you have that, then you want to open it up. Make sure that your communication hub is plugged into your computer using the RS485 to USB that comes with the batteries, and then make sure that you're on the port number. We're on COM5. Port refresh if you don't see it, and make sure that you're connected. You disconnect and connect if you're not sure. Then you'll want to go to your historical data tab. And from here, you're going to pull up the configuration file, and it's going to be the SPI flash data config. So make sure you open that up. It'll auto-populate 0 runtime. You want to set it to whatever the dip switch setting is on your battery bank. So we have the first battery set to dip switch 1. So we're going to do 1 runtime. This should auto-populate. If it isn't, that means there is a connection issue. So make sure that your cables are all properly connected. Then you want to make sure that your entries are from 0 to 10, or however many entries you want to look at. And then you can start. And what that'll do is down here, you'll see that it collected the information and saved the file into RTDS app1. So go to wherever the directory is that you save the file. And there it populated, and it's an Excel file that goes over the battery that you selected the dip switch for. So it has all the information there. And you can do that for as many files as you have. And a new log will be created for the battery every 3 minutes or so. Taking a closer look at the communication hub, we can hold the enter button for about 5 seconds to go into the settings. So let's see here. Now we're in the parameter settings. We can set our maximum charge voltage, which is for the battery bank, max charge current, which is per battery. So this is going to effectively set the limit that each battery will individually be charged at, up to the maximum, of course, that your inverter is capable of. So you're not going to be able to set your charge current higher than your inverter and expect to get more than what your inverter is capable of outputting. You can also go down and change the protocols. So for inverter 485, this is, of course, the RS485. You can set it EG4 0. You have Growatt at 1, Schneider at 2, so on and so forth. So you can select whichever one you have for your situation. Or if you're using inverter CAN, EG4 0. You can go up and down. So like Victron 1, Schneider 2, Growatt 3, SolArk's at 5. But for the first demo, we are going to use Victron. So we select that. You can also change your baud rate, but there's no need to do that. So press back. And on the main screen, you'll see that you can have access to the battery bank's voltage, state of charge, the current being drawn, as well as the battery bank's temperature. It'll give you your system status, which is on standby, as well as inverter status, which is in timeout because we're not currently communicating with anything. You also have the amount of batteries as pack number and the firmware version, which is 1.5. Going down on the settings or on the main page, you'll be able to see wide range of detail on your battery bank per battery pack. So this is pack 1, first battery in the system, and it'll give you a lot of voltage detail, a lot of great things there. So that's what you can do on the main screen, and let's take a look at the communications. The LiFePOWER4 battery does not innately connect with the Victron system, so you'll have to connect your LiFePOWER4 battery with communications up to the comms hub, and then connect your Victron system in through the servo using a CAN communication cable, and you'll see that it pulls up the state of charge as well as the other battery information, and the inverter status is now changed to normal to indicate that it is communicating successfully with the system that it is integrated in with. Alrighty, so now that we have the SolArk protocol set up, we need to go to the SolArk unit, battery setup, select our BMS lithium battery, make sure you hit OK, and you'll see lithium battery info right here, and then we will need to go plug up the SolArk to the LiFePOWER4 Communications Hub. So we'll get that plugged in. We will see there is no error, and the battery voltage now turns to state of charge. We can go in here and see that it is properly communicating with our LiFePOWER4 batteries now. So we'll have that charge current limit, which is 100, because we set it to 50. So we have 2 batteries, 50 per battery. We have 100. Discharge current limit to 100. State of charge 65%, and battery voltage 52.73. So now we're moving on to the Schneider system here. We currently do not have the Insight Home plugged up to the LiFePOWER Communications Hub. So first, what you want to do is you want to make sure that your inverter is plugged into the Insight Home, and then you want to plug in your Insight Home to the inverter's communication hub. And once you've done those 2 steps, then you can go to your setup, and then you want to go to device detection and detect devices. And this is for the RS-485 port range. You want to go 1 to 10, and you want to detect. This will take just a moment as it processes through and looks for the connection. We see detection has been completed successfully, and we found the device. So when we go back to our devices, we will have a BMS that is online, shows our voltage, which is 52.71, temperature of 14 degrees Celsius, state of charge 49%, and state of health 100%. So that's how you have closed-loop communications with the Schneider system using the LiFePOWER4 Communications Hub. Thank you for watching our Communication Hub in operation. Don't forget to leave a like and a comment down below. I'm Brayden from EG4, and I'll see you next time.